Hi there and welcome back. In this video I want to show you how you can create patterned panels just like this one here. Using my Scale By Tools extension, there's different ways you can do that. You can use formulas to come up with designs, or you can use images, which as you can see I did right here. And then you can use different geometries. I used a square for this. But you can use circles and any kind of other geometries to create some really interesting designs. So there's how that can look at scale. All right, so I'll cover that in this video. This is actually a follow-up to one of my Basecamp presentations, basically the part that I did not get to at the end. And so you can very much pick it up right here. Okay, let's get going in a minute. Don't forget to check out my book, Architectural Design with SketchUp. It covers all of these topics and makes for a great desk reference. You can find it where books are sold. There's also a link to it on my site, sketchupfordesign.com, together with lots of additional tutorials and news. Okay, let's get things started. To begin, you will of course need to have the Scale By Tools extension installed. This of course only works on the desktop version of SketchUp, so either the Mac or the Pro version, but it does not work on the web version because extensions can't be installed there. And you get those, of course, by going to extensions, extension warehouse. You look for Scale By Tools and you install it from there, and then you should get this toolbar that you see here. And there's also a menu item under the Tools menu right there that you can use. And you can set keyboard shortcuts and so on and so forth. The usual, basically. Okay, so let's get started. We want to make pattern panels like we saw here. And I got myself two examples there. I'm going to switch my view to top view so that we can experiment a little better and highlight things better, which is very important here. And I'm going to work on this left panel first, and then I'll show you some stuff on the right panel here. In terms of setup, actually, just a really quick one. This requires components. Actually works with groups as well, but components give you a little bit more control over the origin. So I'm just going to show you what I did here. So this is just a square or a rectangle, nothing too fancy, no thickness whatsoever. And when I double click it and go into editing mode, I see that my origin is right in the center of the object, right at the base of the object. So for Scale By Tools and any of this, the tools that we're using here, whether you do it in 2D, which is effectively what I'm doing here, or whether you're doing it in 3D, it's really important that your origin within the component is where you need it to be. If something is supposed to scale upward, for example, then the origin needs to be on the bottom. If something is supposed to scale, outward to both sides, then the origin should be at the center. So whatever you want to do, and there's different ways that you can use this, just keep in mind that the origin has to be where it makes sense. And then, of course, that determines also the coordinate axes within the component. And so then, make sure you set those correctly, because when you set those, obviously you can set them in any kind of orientation. You may be having blue pointing downward or something like this. But in any ways, let's assume that you set up your component just like this, and then you can arrange it any which way you want. I just did a grid of copies of this component right here. As always, this is a little bit more efficient if you use components, because those are all just copies of the same component rather than groups, which can weigh your model down, especially if you have something that's not a square. With a square, of course, we do have 4 edges. With anything circular, I mean, the regular circle starts at, where are we here? At 24 edges. So keep that in mind when you're working with this. Same principle about the centroid, though. Works for any shape. Okay, so I already have my backer board, if you want to call it that way, my background for this panel right here, a rectangle. But for now, I don't need it, so I'm just going to hide it. Okay, so now we can go ahead and experiment. So I'm going to highlight all of my component copies, the little rectangles. And within the toolbar, you'll see what's available. Again, you can find that through the menu as well. But you can transform those by image, which is, again, what I showed you there as a sample. We're going to do that last. You can transform by attractors, and that's something I'll cover in other videos. I actually have covered in other videos already, and so I'll show you that separately. But it's really cool because the scale can then be determined by proximity to something, and that could be multiple objects. Then you can use a power equation, some x squared or something like this. You can use a sine or cosine equation, and those two, use them as you need. If you need something to go wavy, then sine and cosine is usually really great. If you have other needs, then power equation is good, where you can do squared or cubic equations and get different effects from that. I'm not going to cover these last two tools. This is, of course, operating on faces and vertices. We're just going to be operating on objects, and again, in our case here, those are component copies of a rectangular object. Okay. I said earlier, sine cosine is cool. Why don't we use it? Okay, so I highlighted everything here, and I'm going to start the sine cosine tool right here. And now you see that there's your usual directions in there for transformations. You can do uniform scaling, which is about the center of that object. You can scale in red, green, blue. Those are all the coordinate axes that I just showed you within the respective components. So keep that in mind in terms of what you want to do. So scaling, you can rotate, and you can move, and you can decide what you need. If you need to do more than one, so for example, if you want to scale and move, just make it 2 operations, and then you got what you need. So let's assume we want to do uniform scaling. We're just going to make this larger or smaller based on a sine curve right there. And then the curve basically looks like this, where you have an amplitude and a period. And you do have that in the red, green, and blue directions. Now that is now within the overall model, and we're going to use that again when we work with images. So red, green, blue here on the left is in the model. Red, green, blue in the drop down here is within the respective component. So let me show you what I mean by red, green, and blue, because this works in any orientation. For now, mine is reasonably oriented with the coordinate axis, but for finding out what you have, and let's assume you've rotated all of these rectangles at an arbitrary orientation, you can group those. So if I make a group, and if I go inside the group, I see the coordinate system. Again, this will show you something in your respective orientation. Now mine is parallel to the actual coordinate origin and system that I have, but if this were tilted, then of course you can use what you're getting there, and you can adjust that by simply rotating your coordinate system before you group these, and then you know where your new axes are. I might show you that in a separate video. That is a little too involved for now, but just keep in mind, this way now here's your red, there's your green, and if I want to basically map my sine wave either way, then it'll be in the red and green axis if I want to do that in the base here. Okay, so I'm just gonna float this back down so that, you know, this is just, see here, just my geometry. Okay, again, highlight everything, start the tool. Again, we want to do uniform scaling, we want to do sine, and now in the red direction, so the x-axis down here, we're going to have basically just a sine of x. If we have one here and one there, then both amplitude and period are factors of 1, and so it's sine of x. And then in the y direction, or in the green direction, in the vertical here, we're going to have 1 and 1 as well. And that is kind of all I need at this point, because I'm not doing anything in the blue direction, so you can put anything here, but it's not going to affect what I have going, or you can just set this to 0. There's also an offset where you can shift the whole thing. You know, it's basically added as a factor after all the calculations here. Okay, that's a whole lot of explaining. Let's see what this looks like. So keep in mind 1, 1, 1, 1. Hit OK. Then you'll see on the status bar what's happening. And then when it's done, it looks kind of cool, right? So now we've got basically a sine wave going in the x direction, or red direction, and a sine wave going in the green direction. And that scaled all of these, either made them larger or made them so small that at some point they disappear. But you also see that we do have a +1 and -1 thing happening. I see the front of this square on the top right, and I see the back face of the square on the bottom left. Usually it doesn't matter, but sometimes it might matter for you, and you may have to adjust this as needed. Okay, so let's just undo that. And again, the parametric part here is trial and undo. You know, you basically run this thing with a set of parameters. If you don't like them, you undo it. Now I'm going to switch to cosine and show you exactly how that looks like. Obviously that's a shifted wave, and now we've got this kind of bulging out in the middle type thing. And again, you can use this any which way you want. You can actually just have like the z-axis extending, or you can do a rotation too. Why don't we just quickly do that? So if I do a rotation, and we rotate about blue, because we want to rotate in the red-green plane. All right, so if we do a rotation, the numbers down here become angles, because now, of course, what I'm doing is I'm rotating by a certain angle amount. And so now if I say 90, right there, I'm not going to change the period because I want to keep the same, you know, from small to large to small kind of thing happening. So I'm going to switch that to an angle, and then when I click OK, now it's a little hard to see, but you can see how now we have this parametric rotation happening right there. All right, so I just undid that. And I'm going to go back into my tool, go back into this here. And then the last one is a motion thing where you can move things, and that is now by a certain, you know, length of sorts, and you can put a length in here. So if I do 12 for 12 inches, or you can, you know, if you want to, you can add your coordinate system, of course. But I'm just gonna do that. So 12, same thing. I'm gonna go with cosine, and this should look interesting. There you go. So you can do all of those kind of modifications in there. Just keep in mind again that, you know, scaling, all of these are scale factors, rotation, all of these are angles, and then motion, of course, is a length unit. Okay, so I'm gonna go back to my ones right there. Again, this is what I'm getting from it, right there. And now, of course, you can experiment with the factors, and you can go ahead and say, well, in the y direction, I might need to have a little bit more happening. So I'm going to double the amplitude. So then you get that sort of thing. So in any case, feel free to experiment as much as you like, and work with the equations. And again, if you're using the third dimension here, then of course you'd fill those in as well. Let me show you really quickly what happens when I do a transform object by power equation. Again, highlight everything, then click on the toolbar button, and then you get yourself in here. And this looks kind of confusing, I have to admit. All right, so maybe let me just quickly show you what we're dealing with here. If you go to Tools and Scale by Tools, there's actually a little help button, a help menu, which gets you to my website. And on my website, I have a reference manual right there, halfway down. I'm just going to move this over to the side so that we can see things a little bit. Some of these items that I talked about are explained in there, so just make sure you go there to double check things. But down here you see the equations written out in a little bit more readable format. And now you see here for the power for the sine cosine equation that we just used down here, those are the factors a and b, and we only use the first part of that. Now we're in the power equation side of things. Let me see if it opens both. Yeah, right there. Okay, so now you see there's three factors, a, b, and c, and those are shown right here. So in other words, if c is 2, then this is a square. If c is 3, then it's a cubic, and so on and so forth. And then you can start with multipliers as 1. And the power factor is 1. That's basically these here. So now if I do 1, 1, 2, I basically have x squared plus y squared. And that's all there is. And then again, if you need to do something in the third dimension in the blue, then of course you can add that. Or if you need to add an offset, which is the little factor here at the end, then you can do that as well. Okay, so I am going to, well, first of all, I'm going to get rid of this thing here because we don't need it right now. And I'm going to just run this with a square. So again, uniform scaling, same options are up here. 1, 1, 2, 1, 1, 2, so x squared plus y squared. And then we get, drum roll, this sort of thing. Okay, so right here. Now this makes these very small. So now, of course, you can go back and give it a good multiplier. I don't know, 5? Pick and choose. And again, you may have to adjust this as needed, because at some point you may run into this thing where they overlap, and then you got to figure out what you do with that, basically, which is not impossible. You can just have the geometry merge at that point. But completely up to you what you want to do there. And again, if you now want to, maybe in the y direction, have a cubic, then I'm just going to click on OK. And we're going to get ourselves that sort of deformation. There you go. So completely up to you what you want to do with those. The principles are always the same. And this works in 3D. So just keep that in mind. Right now I'm only showing you a 2D application. I might do another video with a 3D application. But this all works in all 3 directions and dimensions and is always based on the local coordinate system within your component. Okay, so that's the 2 equations, equation types at least. The sine cosine equation and then the power equation. Now, the third one that I want to show you is the image. So now let's transform all of these by image, and it works similarly. You highlight everything. At this point you need to know very well where your red, green, and blue global axes are, because the image will be, projected of sorts, or will be mapped to a pair of coordinates. So either the red-green axis or red-blue axis, and so on and so forth. And again, group this and then find out where your overall coordinates are before you get started. But other than that, click on Transform Objects by Image right here. And then you get these options. The top drop-down is, the same as before, uniform scaling, and you can do all of the other things too again. I'm just going to do uniform scaling again, but feel free to use whatever you want to. The second drop-down refers to the image orientation, how it maps onto what it is you have there. And you always have to work with this kind of mapping because your image is 2D and whatever you're scaling may be 3D, so you need to figure out a way to make this work. So I'm going to use red-green because that's my XY coordinate system right here. Multiplier, well, we can just leave that at 1 right now. But what happens here again is, as before, it's a scale factor. If you're scaling, it's an angle. If you're rotating, and it's length if you're creating a motion in a particular direction. So multiplier, 1. And this last option is going to be in my new version of this extension, where you can actually have an option to invert the image. Right now, you just have to invert in your photo editing software and then use an invert of an image, but it'll be available very soon because I find that really useful. Every once in a while you just need to invert it to make this work well. So I'm going to leave this as no for now because it's not available yet. Okay, so then click on OK. And now you'll have to provide an image, and it really doesn't matter what you use at this point. This can be color image, can be grayscale image. Basically what happens is that everything gets converted into grayscale, for one, and then the aspect ratio gets mapped to what you have as an outer perimeter. So if I use my square image right here of that wave, and again you can kind of see down in the status bar what happens, then that gets mapped onto my 2:1 aspect ratio that I have for my panel. And that can be interesting, but keep in mind that happens so that you're not disappointed by the result. And then same as before, we scale by a particular value. In this case, it's of course a grayscale value. Now let me show you something that's not based on a formula. Again, same dialog. I'm going to use the S here. And then you get that. One thing that I've found is useful if the image is slightly blurred, because otherwise you get not very smooth transitions between sizes. So unless you absolutely need to have hard transitions, I would always blur it a little bit, because the problem is that sometimes when this extension tries to find a point at this point or at that point, it might hit a particular pixel, and that's not always sharp, and so on and so forth. So it's just it may get messy if it's not slightly blurred. So good tip here, blur it slightly. You can use a Gaussian blur or something in your image editing software. Now, if it's a photo, right now, you gotta use it either as an invert or as a regular photo. It can be color, it can be black and white, completely up to you. But I'm just gonna use this one. Again, later on, you can click on the invert button and it'll be inverted for you in the extension. Okay, now I'm gonna click on open, and all of that gets applied like this here. All right, there. There you go. Now we've got ourselves our photo on there. Okay, so all of that was step one, basically. And I'm gonna just undo my height from way back when, which is the background of my panel, because now what I want to do is I want to cut these holes out of that panel. And that, of course, requires you to break down the geometry for the whole thing. So there's different ways you can do this. One doesn't seem to work overly well, at least at this point. But in principle, if you highlight this whole thing, click on explode, it should explode everything. And now this takes a while, of course, because you have lots of little components there. And usually what I like to do too is I'd like to copy my original grid and then work on copies of that so that I can always go back if I need to. So here we are. So now we've got this not exploding overly well. So another way you can do this is I can highlight my rectangle and explode that one right there. Then I can right here highlight everything and then intersect faces with selection. Again, this will take a while. And what I'm trying to do here is basically I'm trying to intersect all of these rectangles onto my background rectangle right there. So it's still thinking, but at some point, there we go, this should be done. And so then all you need to do is highlight the back. Then I like to just copy it off somewhere. And then when you copy it somewhere, you'll see how these very nicely intersected and basically cut out. And then you can just use your push-pull tool to give that the required thickness. And then you can group the whole thing or make a component of it. And you get yourself your panel right there with thickness and all. Right there. Okay, so that's in principle how you go from your rectangles or your adjusted sizes here to a panel. Feel free to modify that process any which way you want, whatever makes sense for your workflow, of course. Now, this doesn't have to be only with squares. You can use any kind of shape. So I'm just going to do that with these. Oh, actually, before I do this, with these triangles. And again, as before, the triangle center is really important because that's the point about which the scaling will happen. So now in this case, I found the centroid for those, and I'm using that. I can do that. I can go back in and do an image. Then I got myself something like this here. So there's all kinds of ways you can use this. You can actually, once you have something in 2D, you can map it onto 3D objects with a Flowify extension. There's actually some videos out there that walk you through that. So it's a really nice one. But yeah, all kinds of fun you can have with this. So again, Scale By Tools, what we walked through today were basically the equation parameters, sine cosine equation, the power equation, and the transform by image. And then that process of how you convert that into something, that you can then fabricate. One question here is, of course, how you're going to fabricate it. If you laser cut it, this is easy to do. If you, CNC cut it, then of course you may run into, rounding things, or you may want those. Anyways, so there's all of that discussion to be had too, but you can at least get to the point of having your geometry in panel form. All right, hope this was useful, and I'll see you here soon.